Hi everyone, this video is on exercise 9G question 6 of Pure 2. So this section is all about parametric differentiation, and in this question, which is an interesting one, we have the curve C with parametric equations as x is equal to t squared minus 3t minus 4t over t, and y is equal to 2t, where t is positive. And the interesting thing about this question is that we have a line L, which is the tangent to curve C, and just imagine that this is just a random curve that I'm just going to sketch. Let's say this is the curve, and what we have is that line L1 is the tangent to curve at C. So, sorry, at a specific point. And let's say this is the point, for example, and this is a tangent. Then what it says is that the tangent is actually parallel to the line with equation y is equal to x plus 5. So that's just a very useful fact in this question, that uh, this blue line is parallel to, let's say, this line. Again, this graph is not accurate by no means, but we have a such situation. So now, what we need to see, or actually what we need to find, is that the equation of L1, which is basically the tangent, we want to find the equation of the tangent. Okay, so the first step is, as usual, we need to find a derivative, and the next step is going to be different because here we have some specific type of these types of questions. So first, let's find the x dt. Before I find the x dt, we can simplify x because we can divide every term by t. So t squared divided by t is t minus 3t divided by t is minus 3. And then we have minus 4 over t, which is minus 4t to the power of minus 1. And y is just, doesn't change. So now the x dt is equal to 1 plus 4t to the power of minus 2, and divided t is equal to 2. So now we can find dy dx, which is divided t divided by the x dt, which is 1 plus 4t to the power of minus 2. Okay. Now, in usual questions of parametric equations, once we find dy dx, we normally, are given the value of t. So we substitute the value of t into dy dx to get the exact value of the gradient. But in this case, we don't have the value of t, and what we need to do is that we need to find a value of t. But how can we find that? So the answer is here. Because just think about this question and see what's happening. So your tangent, which is L1, is parallel to x plus 5. Y is equal to x plus 5. And we know that two parallel lines have equal gradients. So the gradient of x plus 1 is 1, x plus 5 is 1. So therefore, L1 must have the gradient 1. Okay, so we now know the gradient dy dx is actually 1. But we don't know t, and we need to find t. So the reason we should find t is because we want to find the equation of the tangent, and in order to find the equation of the tangent, we need to know the gradient and the coordinates of that point that the tangent passes through. So in order to find the coordinates of the point, we need to find the value of t first, and once we know the value of t, we substitute that into the equations of x and y to get the coordinates of the point. So now we want to solve this equation. So let's do cross multiplication first. We have 2 is equal to 1 plus 4t to the power of minus 2. So that's the first step. We can now rearrange this, to make this nicer. So subtracting 1 from both sides, we get 1 is equal to 4 over t squared. And then another cross multiplication gives us t squared is equal to 4, which means that t can be positive or negative 2. However, if you look at here, t is positive. So t only has one value, and it's actually just positive 2. It can't be negative. Okay, now we know the value of t, which is 2. What can we do with that? That's simply the matter of substituting t into equations of x and y to get the coordinates. So when t is equal to, then x is equal to y is equal to. So y is equal to 2 times t, 2 times 2, which is 4. And then x is equal to, so substituting t into here, which is 4 minus 3 times t, which is 6, minus 4 divided by 2. So this gives us minus 3. So the coordinates of the point that is here, let's say point P, has coordinates minus 3, 4. And now we are at a position, and we know that the gradient is just 1 at the tangent. So we are at a position to find the equation of the tangent using the formula y minus y0 is equal to m times x minus x0. So y0 is just 4, m is 1, and then here we get positive 3. So rearranging that gives us x plus 7. So this is the equation of the tangent. So we first found the derivative, and then we knew that the gradient is 1 because the tangent is parallel to the line y is equal to x plus 5. And then we found the value of t. We used that to find the coordinates of the point P. And finally, we found the equation of the tangent. Okay, that's it for this video, and thank you for watching.